Okay guys, in this particular lesson what we're going to talk about is cellular respiration. We're going to talk about all the different processes that occur in cellular respiration. So the first thing that we're going to talk about is the fact that cellular respiration is how your body is going to get the energy out of the molecules that you eat. So what we're really talking about is that we're getting energy, and we should know that that energy that we're talking about is ATP, and we're getting it from molecules, and those molecules are really food. And we should know that when we're talking about food, what we're talking about is organic compounds. So this is how we're going to extract that energy out of those foods so that we can use the energy in order for all of our life processes to occur. There are three different reactions that we're going to focus on when we talk about aerobic cellular respiration. We're going to talk about glycolysis, the citric acid cycle, or as you guys formerly knew it as the Krebs cycle, the electron transport chain, which can also be called oxidative phosphorylation. Anaerobic is going to include an additional one, which if you'd like to include, is going to include the process of fermentation. And I also want to point out that what's going to come out of cellular respiration, depending on what type of cellular respiration is occurring, cellular respiration is going to produce carbon dioxide, water, as we already said, ATP, which is that chemical energy that we're looking for, and it's also going to produce some heat. So there are two different types of cellular respiration. We have aerobic, and we should know that by using that word aerobic, aero, we're talking about a requirement for oxygen, and this is where the most ATP is going to be generated, versus anaerobic. We put an "an" in front of it, and we should know that it's without, and that's going to produce very little ATP, but still some. So the first step that we're really going to focus on, or the first process of cellular respiration, is called glycolysis. Glycolysis is actually going to be the start of both aerobic and anaerobic, so it's important to recognize the fact that glycolysis is the first step that occurs in either one of these pathways. It occurs in the cytosol, which we should also know we're referring to like the cytoplasmic area, and it does not require oxygen. So technically, it's anaerobic because there's no oxygen needed. So it's technically anaerobic, but it's a step in both of the different processes. And we should be able to also take this word and break it down into glycolysis. Lysis, we should know, means to break apart or break down. And glyco is the prefix that we are using for glucose. So glycolysis is the process of breaking down glucose. And it's kind of the first step in the process. So this picture is just showing you what I'd consider to be a kind of confusing image of glycolysis. We have glycolysis is taking place out in the space of the cell. We have our 6-carbon glucose molecule moving through the different processes. But I think there are some better ways that we can depict this. Glycolysis is actually a series of 10 different little like mini reactions that all kind of sum up into the splitting up of the glucose molecule. And essentially what happens is that one 6-carbon molecule is split in half into 2 3-carbon molecules. And that 6-carbon is called glucose, and the 2 3-carbon molecules are pyruvic acid, or as you guys previously learned them as pyruvate. Glycolysis is actually going to produce an overall gain of 2 ATP, and there are 3 main events that occur in glycolysis: phosphorylation, the splitting, and production of the NADH and ATP. So we're going to talk a little bit about each of those. So phosphorylation, really fancy word. for adding phosphate. So in phosphorylation, we have two phosphates that are added to the glucose. So as we see here, we have our glucose molecule. And what's going to happen is 2 ATP, right, triphosphate, we've got 1 phosphate, 2 phosphate, 3 phosphate, are going to come in here, and if each of these molecules, remember there's 2 of them, so there's 2 triphosphates, if one phosphate comes and is added onto one side and another phosphate comes and is added onto the other side, then that means that you're only left with the diphosphate, 2 phosphates, right? So that's the first step here. We add phosphate onto the glucose molecule. And like I said, it requires 2 ATP in order to do this. Then the second process is called splitting or cleavage. That word cleavage should sound familiar from when we talked about cellular division. Cleavage furrow is what forms. So cleavage, we're talking about splitting. The 6-carbon glucose which isn't really actually glucose anymore. As we can see here, the name has changed because of the addition of the phosphates. It's going to split in half, and you're going to get 2 3-carbon molecules, but they still both have that phosphate attached. Then what's going to happen is that you're going to have a production of NADH and ATP. And the way that that happens is that this chunk of what you see over here is really actually happening to both of these molecules. So 1 NADH for one of them and the second one for the other molecule. 2 ADP for one molecule, 2 ADP for the other molecule. This picture kind of shows it confusingly because it shows it almost as if only one of the molecules goes through this process, but when the fact of the matter is that both of these 3-carbon molecules is going through this last process, it's only really just showing the summative process. So what's going to happen is that 2 NAD, which is the uncharged, right, our uncharged version of this temporary energy molecule that's going to carry energy on to our last stage, it's going to come in and it's going to pick up hydrogens. So it's going to become charged. And likewise, our ADP molecules are those uncharged. They're going to come in and pick up these phosphates, right? Plus, you're going to have an addition of other phosphates to get 4 ATP, which is the charged version. And what you're going to be left with is just the 3-carbon molecule, no more phosphates on it, which is the pyruvic acid. And then don't worry about what you see down here. What you see down here is after this process. So what we're ending with here is 2 pyruvic acids. We've gotten 4 ATPs, but remember, we had to put into to gain 4, so we're really only ahead by 2. And we got 2 NADHs. That NADH is going to play a role later in bringing the hydrogen and that temporary energy, the electrons, to the electron transport chain where oxygen is present and where energy can really be generated. So ADP is phosphorylated. Remember that phosphorylated, that word again is just adding phosphate. So here we have the ADP adding phosphate to become ATP, diphosphate becomes triphosphate, 2 becomes 3. And in the end we have those 2 pyruvic acid molecules, 2 pyruvates, and they're going to be what moves on into the next process. We're going to talk about anaerobic cellular respiration first, and we should know that anaerobic cellular respiration is obviously what happens when there's not enough oxygen present for aerobic to occur. I told you guys before that fermentation is the name of the process. And what's going to happen is that when that oxygen is not available, which is, now we're talking about beyond this point, right? Over here you'll see that this is when there is oxygen present. That's not what we're focusing on. What we're actually focusing on is this, when there's no oxygen present. And when there's no oxygen present, that NADH that was produced is going to move on into the fermentation process, and it's going to get used. because it can't move on to the electron transport chain because electron transport chain is an aerobic. So it's not going to really be able to generate the large amounts of energy that you hope for, but it's going to get used slightly. So the pyruvic acid, in that process of using the NADH, the pyruvic acid gets converted into lactic acid. And then your uncharged NADH is able to go back up into glycolysis and continue. So long as that NADH continues to cycle, glycolysis can continue to happen, and so long as glycolysis can continue to happen, small amounts of energy can be generated. But it's not enough really for survival, at least for not organisms of our size. Like I said, there's less ATP production than aerobic reactions. And a few last things to talk about is the idea that lactic acid, we should know what lactic acid buildup feels like. Painful, burns, sharp shooting pains, cramps. What actually happens is that as that lactic acid builds up, right, this product of anaerobic cellular respiration, as it builds up, because there's nothing more to do with it. This is the end of the road for anaerobic cellular respiration. This is the end product. As that lactic acid continues to build up, glycolysis actually gets slowed down. So ATP production gets slowed down, which means that obviously you're not generating very much energy, and it's not going to do very well for survival. But the interesting thing is that the lactic acid passes into the blood and it travels to the liver. And in the liver, when oxygen becomes available again, that lactic acid can actually be converted back into pyruvate. And if it's converted back into pyruvate when there's oxygen available, then it can take that aerobic path for more energy to be generated. So the damage of anaerobic cellular respiration is not permanent. It can be reversed once oxygen becomes available again.